So, hello everyone. My talk is going to be about the journey my team and I have gone through in order to build a robust and easy to maintain application. Now, the title of my talk is Rx-powered Functional Reactive Flux. So many buzzwords, but hopefully until the end of the talk, most of them will be understood. My name is Mazuz. I'm the head of frontend at NSO Group, which is a leading cyber company. The story begins with my team and I receiving a new project, a big project with a lot of features, and also the work in my company is very dynamic. You get features getting in all the time. And you want to handle this appropriately. So we had a few goals for this project, and we wanted to achieve those goals. The first goal we had is for our application to be scalable. Now, when I say scalable, I don't necessarily mean scalable performance-wise. I mean actually scalable feature-wise, which means when the application scales up, how easy it is to add another feature to it. The second goal we had is to be frameworkless. The reason is that we prefer libraries over frameworks. Frameworks are great, but we prefer to have full control over our code. And usually when you use framework, it helps you 80% of the features you need, but for the last 20%, you need to almost rewrite half of your application. So that's another goal we had, to have only frameworks and not only libraries and not frameworks. The third goal we had is to have a clean state management. When I say clean state management, I mean no normalizing the state. I don't want to hassle with the state. And I would like to have a single state for my entire application, because when you have a single state, you can review it each time. Each point of time in the application, you can see exactly what's its state. So a single, easy and clean state was very important for us. State first, that's another goal. State is the heart of the application. When you're doing state first, it make it easier. Also React, this is the React way, the true React way. React is function of state. So you need to begin with state. And then you can, of course, move it on the network. You can pass it on the network, you can also persist it to a file or do whatever you want with it. So that's another principle we had. And the last principle is to have a clean React. We didn't want to be obtrusive towards React. We didn't want to change it. We didn't want to monkey patch it. We just wanted to use React the way it is. It's easy for us then to share components, maybe to put them open source. And we didn't want to hook it up with the way we do things. So, of course, React was our choice for the Vue library. I mean, this is a React conf. We all like React. However, what about the data flow? Now, we didn't want our data flow to look like that. There are several options for data flow in React, with React. The first we've examined was vanilla Flux. Now, vanilla Flux, pattern-wise, is actually pretty great. We liked it a lot. But the problem we had was with its implementation. First of all, it's a framework. It violates our second principle. Second of all, vanilla Flux also has so many moving parts. You have the stores sometimes you need to wait for other stores, and it's too much boilerplate just to make easy stuff. So we moved on to the most popular Flux implementation today, Fluxish, I would say, which is Redux by Dana Abramov. Now, Redux is a very cool framework by Dana Abramov, but again, too much boilerplate, thing we didn't like if you'd like to scale up your application with middleware, then you need to monkey patch, store dispatch, and doing all this kind of things. Also, state. You should normalize your state when you're using Redux, and we really didn't like it. So we moved on. We moved on and examined CycleJS. Now, CycleJS using streams or observables, which I'm about to talk later on. CycleJS is a framework by Andrei Staltz. This framework is actually pretty great. theoretically. The idea of the user as a function is a very good idea. However, when we try to do something more bigger than a BMI slider or a simple example, it didn't scale up. The reason for it is that he's very much trying to be fractal. It doesn't have a common state, for instance. It doesn't have a mutual state, which you need, because sometimes you need a mutual state that several components takes properties from it. And so it emits VDOM and also data, and you need to hook up to this data, and it didn't scale up so well for us. A library that we've also checked was React Combinators by Matti Laniken. This is a really cool library which allows React to receive props, not just plain old JavaScript objects, but also to receive streams as props. And that's a really cool library. The only problem with this library was that it's obtrusive towards React. It changes the way React works, and that violates one of our goals. And last but not least is MobX, which you've heard about earlier this morning. Now MobX is, if we have FRP, it says it's TFRP, Transparently Functional Reactive Programming. I would say it has the R. It is reactive. It doesn't have so much the functional part. It advocates more of an object-oriented programming approach. And you have to have like data binding. It's not just a functional approach, it's data binding. You need to hold your references behind, and it's very similar to MVVM, Model View View Model approach, which some like, but we didn't want to use it this way. So what did we do? We actually took RxJS and implemented Flux with RxJS. So what is RxJS? RxJS is a library that helps you implement with a paradigm of functional reactive programming. It helps you manipulate event streams with operators. And one of its best features is that time is not a factor, which means you don't need to think about the time, you need to think about a process. And I'm about to elaborate about this real soon. So what are observable streams? Let's just see the example around here. Here we have two streams. We have the stream above and the stream below. Now, the arrow represents time, okay? Represent the time flow. So we have the first stream have red element, and after that green element, and then the X means that the stream is completed. And we have another stream that have yellow and cyan and purple element. And we use operator merge for those two streams, which outputs a new stream with all of these elements. So all of these elements will run over time with the output stream. That's observable, or stream. But we said functional reactive programming. So functional reactive programming contains two parts. We have the functional part, and we have the reactive part. Let's break it down. Let's begin with the reactive part. So what is reactive? You always say reactive. What does it mean? So we all know interactive. We all know interactive because this is the normal way. Interactive means that, let's just say we have module C, and we want to affect it. In order to affect it, module C needs to expose an API, a public function, let's just say change something or add to do or whatever. And module A and module B need to proactively invoke this function. So if I'd like to see how module C changes or updated, I need to look for all of the modules, all in my entire application that influence or affects this module C. And that's not so good. And you can't be reassured that when you change something, it's gonna be clear because you don't know who changes module C. Everyone can change it who has access to its public API. Reactive, on the other hand, is exactly the opposite. Module A, Module B, and Module C are separated. Module C is separated, and Module A and Module B do not know him. Does not know Module C. Module C reacts to Module A and Module B. It reacts to it, so when Module A changes or Module B changes, Module C does something. But Module A and Module B cannot change Module C. They don't have access to it. Module C can only react to other modules. It's independent. This module, it's independent. Now, this is a very powerful principle, because now when we look at module C, we can see all the ways and all the behaviors and all of its dynamic behavior and the way it can change. Because we know no module can change it from the outside. We know it only reacts to other modules. No one can change it proactively. And against the interactive example where module C was passive and module A and module B was proactive because they acted over it, module C is reactive. It only reacts to change of module A and module B. Now, I think the best selling point of reactive and RxJS is to have all of your dependencies, all of your dynamic behavior in one place. It gives you a peace of mind, because when you see a value, you can know all the way it could change. You can be rest assured that no one can change it anywhere else in your application. You just see it in one place, no one else can change it, no one else can do a mistake, because this is a reactive way. Let me show you this by an example. Let's just say we have a variable A, which we assign to it 5. Now, and a variable B that has the behavior of A times 2. Now, B equals, obviously, 10. But if someone in the code will put A equals to 8, which means we'll assign 8 to A, B will not be updated. So when I look at B, I cannot be rest assured that this is exactly the behavior. Like every A in the world will be multiplied by 2. This is not the case. In streams, it is the case, because when I define stream A, I define it to be observable of 5. That's the only place I can define it. Can I declare it? And stream B right now equals to stream A, mapped that every A will be multiplied by 2. Now, stream B cannot be modified anywhere else. I declare all of its behavior in one place. Because streams allow you to specify the dynamic behavior of a value completely at the declaration time. That goes also for stream A. So if we'd like to try to reproduce the example before and we'd like to add A, I cannot just do now stream A equals to 8. It doesn't happen. I need to do stream A equals to observable of 5 and 8. Because also stream A has all of its dynamic behavior at the declaration point, and only there. That gives you a peace of mind. And of course, stream B, when it's mapped, it mapped to 10 and 16 accordingly. Now, let's go over to the functional part. Functional means clean and modular and reusable, because we can use small functions which are pure. But when I'm saying pure, I mean they do not do any side effects. They only do computations, like mathematical functions. They receive a value and input, and the output's an output, and that's it. They don't change anything in the outside world. Now, we all know, I can show this by an example of an array and an observable. We all know arrays, right? Now arrays have, let's just take an array with a value of 1, 3, and 5. Arrays are values over space, okay? We have all the values and it takes space. Now we can see that you can do, and we all know that we can do, use functions over those transformations over this array. So we can do map to transform it, and reduce to reduce it to a scalar, and also to filter it according to a condition. Well, with streams you can have the same thing. The only difference is that streams are values over time. For instance, the number 1, we get it right now. The number 3, we get it after 3 hours. And the number 5, let's just say after 5 hours. But the pretty thing here is, the beauty here is that we can still relate to that as we have all the data right now. We can still do map to transform the data. We can still reduce it to a scalar, and we can still filter it according to a condition. And that's a very powerful stuff, because it gives us the ability to make transformations over async operations. We don't care about time. We just do manipulations over it. So what and how did we use RxJS? You probably know or recognize most of this diagram. This is Flux, you might say. But yeah, this is Flux, the pattern. The implementation is completely different. So the flow here goes very simple. Services, which I'm going to talk about later on, or user interactions, going to invoke actions that are going through the dispatcher. The stores react to this stream of actions, and the view reacts to a single state that is a combination of all of what the store's emitting. And then we have it. We have our view, the entire view for the application in a single point of time. So let's break it down. First of all, actions. Well, actions are things that happened in the outside world. We use past tense because they already happened. We only need to react to them. And the most important thing about actions that they are a unified language. We know that if we'd like to communicate with our application, the only way we could do that is through actions. We don't have any other way to mutate or change the state of our application. That's the language. You want to talk to our application? Just use actions. Now, actions contains type and payload, that's all. The type of the action and payload, you can put whatever data you want. One thing which is important to emphasize is that the data should be full. An action always come with a full data, always come with a full data. So let's give an example. Well, the code here is quite simple. We can see how actions are created, game restarted, pattern added, and so on. So we can now mark scalable. Remember our goals? We have scalability here, because if someone wants to add a new feature, he only needs to think about the new thing that happened in the outside world, the new action that he wants to add. Because you just need to think, okay, what do I need to add here? What do I need to add in order for me to comply to the feature I received? There's only a unified language to communicate with the application. It simplifies your mental model. So it's very scalable feature-wise. So we have that. The dispatcher. The dispatcher is maybe the most important part of this architecture. It's the gateway from the outside world to our app. And when I'm saying outside world, it's from the imperative world, which we have plenty, to our nice declarative functional world. It's stateless, it doesn't store any state, and it's centralized. And the reason it's centralized is because we want to track everything that happens in our application. Nothing can change our application if it doesn't go through the dispatcher. It's the gateway, it's the gatekeeper. And that's a very powerful thing. So the dispatcher in RxJS is what we call a subject. Now the difference between a subject and a normal observable and normal stream, as I've demonstrated before, is that subject is a special observable that allows you also to push elements to it. And that's the only subject we have in our application. That's the only place that we are allowed imperatively to push elements to our application. And those are the actions. So the dispatcher has two parts. It has the dispatch action, the way that you push actions to it, and it has the action stream that comes out from the other side. So the dispatcher actually gives you a stream of actions. Frameworkless. Look, we didn't add any special thing. We just used RxJS, which is a general use of functional reactive programming library. We didn't do anything special. We just created a subject. And this subject helps us to have the gateway to our application. Stores. Now stores are the heart of the application. Those are streams with pure transformations. Now I emphasize the word pure. They do not do any side effects. They don't do AJAX calls. They don't do anything. They are decision makers, CEOs, state managers. What they actually do is react to actions and decide what happens. They represent the state and action function which emits a new state. And they also prepare handlers. Now this again gives you a peace of mind, because you know that states cannot change anything in the outside world. They just react and emits a new state. They just do transformations, pure transformations. But they are the most important thing because they what emits our state. They hold our state, our cache. And they also prepare handlers because they also, in a way, expose the way that they can be manipulated. Handlers only dispatch actions. So in a way, it's a good place to put them. Because we want the view to be as dumb as much as we want. To be as dumber as we want. So let's take an example for a store. We have here on the code, let's just say we have a new pattern, okay? Now what it does, it's taking an action stream from the dispatcher and filter it according to the type of pattern activated. We only want to react to pattern activated. And we of course plug the payload because we want the data. And now I'm taking current color. I'd like to choose the current color. I'm taking new pattern. I switch map it to colors, which means I convert the stream to be a stream from a pattern to a stream of colors. And I map each color to be animated by adding a delay to it. Then I'm concatenating it all and starting it with transparent, so this will be my initial value, like a constructor. Now, the amazing thing here that if any feature will get into our application, anything that we would like to change in current color, this is the only place that we can change it because we have all of our dependencies here. So any change will be only here. And that gives us two or more of our goals. It gives us a clean state management because we don't need to normalize anything because our states are reactive. Our stores only react to action from the outside. And we also have a single state because each store handles its own business logic, its own domain, but eventually they are all combined to one single state. And we also have the approach of state first because they first emit an initial state. We start with them. They are the heart of the application. They are the managers of our application. The view part. So, as we said before, the view should be as dumb as it can get. We have a clean React, just a tree of React components. We try to make it stateless as much as we could. Sometimes, you know, there's a class that somehow infiltrates, but we're trying to make it stateless and functional. And parent takes care of its child. So that's the way view works. So you all know this syntax. We have a caller viewer, which takes a caller and transforms it to JSX, which eventually will be transformed to HTML. But the thing that it's important to emphasize here is look how the root of the view gets its data. We have the app store, which is the stream of the entire state, the single state that is combined from all of the other states. We subscribe to it, and we take a snapshot of this state and just throw it to React from the root. And anytime each of the stores are going to change, the single state is going to change and the view is going to re-render. Now you might think, okay, is this performant? Of course it is. If you use functions, you can do memoization. You can do pure rendering quite easily. Just make a base component which has a pure rendering function, a should component update, and you're done. And for the stateless component, just use memoize. And you're okay. You use functions. So functions could be very performant if you'd like. So we have another two of our goals. Separation of concerns, because now the view does not know the data, does not know the state, does not have an AJAX call from our components or thing like that. So we can separate the view and data completely. And we also have clean React because look, this is a clean React. We don't do anything. We just render it from the root. It's a clean React rendering, and we can also share those components to other people. User interactions are, well, handlers and event handlers like onClick, onChange, which you have in React. So the handlers themselves just dispatch action. Let's just take this simple example of add row, which what it does, dispatch an action of row added. That's what it does. It's taking it from the store. It doesn't know even what it's doing. The view doesn't know what is invoking. It's just taking it and taking it as a callback, a handler for the event it has. Services. So you might wonder, okay, you said that everything is pure, so how things are going to happen in our application? So services are exactly for that. They are for the side effects. Now, there are streams that they are responsible for side effects. They can listen to action, react to them, and also dispatch actions by themselves, because streams are in the outside world. They are not pure. They're outside. They can communicate with the dispatcher, but they're not part of our app. Streams and the services could be Ajax services, WebSockets, log. And this is very extendable because we can merge all of those services and have a stream which emits all of what those services emits, each action that they emit. And that's a very powerful thing because we can add any service that we'd like. Anything that have a side effect can add to the list here. So let's take an example of a routing service, a push history service. It receives a dispatcher which reacts to actions.route change. This is what comes from the stream of actions. And what it does is taking the route and actually doing a push state to the history API and changing the URL, because changing the URL is a side effect. That's it. We're not allowing anything else except from services to change something in our application. It makes a clean separation. And it makes it scalable. Again, the goal of scalability is being achieved because we can add as much as services that we want. And all we need is that the service eventually will dispatch the right action. Let's just say we have an Ajax call. So let's just say someone clicked, I'd like to receive users. So user's requested action will be emitted. Two modules are going to listen to it. A service model, an Ajax service model, is going to go and do an Ajax call with that user's requested. And when it's done, it's going to emit users received with all the data. Another module that's going to react to this action of users requested is going to be the store. And do you think why? The reason is to do a busy indicator, because while we still didn't get the data, we want to have a state of is loading true or pending or something like that. So again, a clean separation. So let's do a recap. So reactive models, we have pure module business logic stores, and we have view components. And the side effects are DOM, HTTP server, WebSocket server, logger. We can log all of our action. We can just hook up to our dispatcher, which is the centralized point, and see all what happens in the application. Exception manager, and so on. The advantages of this approach, it's a very simple mental model. It's very easy to add features to it because you know exactly what you need to do. It also allows you to have event sourcing. We actually added a service in my company that hooks up with Redux DevTools, and it works amazingly. We have time traveling with our application. It was pretty easy for us because we have actions and we have pure states. And everything is cool because it just works. And we also have a clear declarative flow. A clear declarative flow means I just need to think of what I want to happen and just write it down. The disadvantages of this approach, and there are some, is that it has a high learning curve. To learn RxJS is not simple. It's a very complicated library, and it's a mind bender. You need to change the way you think. You need to start thinking about what you want to do. You need to start thinking with processes and not just how I'm going to do it. I'm going to do a for I equals to 0 and so on. You need to think, what do you want to happen? And to be honest, debuggability is not amazing out of the box. The reason is that when you try to debug an ASIC stream and you put a breakpoint, you don't get to the right stack trace that you'd like. However, we mitigated this problem because of our centralized dispatcher, because we just hook to it and we can see all the actions that goes to our application. So it's game time. I ask you all to put out your mobile phone. If you have Android, you can just get into this link, and if you have iPhone, please do it via Chrome because we have a bug with Safari, obviously. And don't worry, we're not going to hack your phone. So please get into req.net, and we're going to show you a game. Now this game is a memory game. What happens here is you're going to get a pattern of colors. and you need to retrace this pattern of colors. You need to reproduce it. Now we're going to begin with 5 colors. It's not that easy, and we can also see who wins. So let's begin. Okay, 1 second. Because I'd like to show you something while we're playing and having fun. So what I'm about to show you is the way our paradigm works. Yeah. So look, do you see all those arrows? Do you remember the architecture I've shown before? So now we can see are all the actions that are going through from the services and user through the dispatchers to the stores and to the view. And we can see the state here changes and the action changes as well. So everyone is ready? Everyone has the game? You have to put more than 3 letters on the user and on the password. Everyone ready? All right, so let's begin. So the first level we have is this. Now, while you're playing, you can probably see, look, the current color changes. Look how it changes. The state here changes. And the action also changes because we have new actions. Now we have stats updated. We have a lot of failed users here. Wow, only 4 successful. 5. Interesting, and we have an Hall of Fame. All right. People, you can see your name here, so this is really nice. So yeah, I think we're gonna end this level. Okay, so we have 6 successful users, so let's go to the next level. Again, look at how the actions go through here. Look, I want to thank, by the way, Omer Spalter from my team who developed this game based on our architecture. So let's begin with a new level. So again, look at the action flows here. So we have more failed users. Ooh, only 2 successful users. No. Oh, you're too good. You're too good. We're not going to end this thing. Okay, let's end the level. Another level. So again, look at the state changes. That's the way it flows. Now, an important thing maybe to emphasize while we're playing is that we have actions on the server and on the front end as well. We said that we have a unified language, and that's an important thing. Even the server emits actions because you don't need to know which API you need to use. You don't need to know anything. All you need to know in order to hook up to the application is just emit, dispatch the right action. It's a very powerful principle, and opposing to other frameworks like Redux, things are really separated. We don't need to monkey patch anything. Our services are separated completely. We don't need to monkey patch store dispatch. We don't need to do any changes because everything reacts to other part of the application. Any module reacts to the other modules. They are all separated. And we try to do pure functions in order to transform it. It allows us to have a clean data flow. So let's do end level. Let's see where we at. Okay, 3 people. I don't know to read Russian, so you need to excuse me. Alexander Big, Shlomi Amsalem, and Aviad. You are 3 contenders. So next level. Exciting. Let's see who will win. So while we're doing that, hopefully you're not like this right now, and you understood most of the principles and understood the advantages. And I'm open to Q&A right now, if someone wants. Yes, you should probably go there.
Not to disturb everyone, I will be just loud enough.
Excuse me?
I will ask from here, okay? Just not to disturb people. I wanted to ask how you made your server to emit actions, actually. Is it a WebSocket or what?
Here we're using WebSockets, but the transport layer is not important. That's the pretty thing about us, because the transport layer, we just outsource it in a way to a service. The only important thing is that whatever thing that comes from the outside world, the server too, just needs to emit actions. That's all. That's the interface we have. But thank you. It's a good question. Anyone else? Okay, let's. Okay, next level. We have only two, so we're gonna stick with that, and I think we'll finish by. Okay, let's see who will win between those two. Any other questions in the meantime? Yeah. Yeah.
Hey, so any reason why you think Reduxes and Fluxes dispatching from different sources, like for instance DOM events and AJAX events, are inferior to streams with RxJS that sort of unify them all? Because in a way they're really similar with those different event sources like DOM events and AJAX stuff, because it's all sort of event loop stuff.
When you want to add another service, another side effect from the outside, you need to monkey patch the store dispatch. Now, another thing you have is all those reducers, all of this normalization of state. You always need to handle it. The state. You need to give extra time just to handle the state. In our case, the services, the middleware, is completely separated. It doesn't know anything. It just needs to emit action. It's not connected to the dispatcher. That's the most important thing. It is not connected to the dispatch itself. It doesn't know it. It only needs just to dispatch actions, and that's it. And we also have all the power of RxJS, which means we can transform all of the streams, and we can see all what happens in our application in one place. Again, in one place when we look at it, on declaration time. So, excuse me, let's see if we have a winner. And we have a winner, which is Alexander Big. Let's all give him a round of applause. And I would like to thank to Omer Spalter from my team for developing the game, Tali Rosh that helped designing it, Doron Zavalevsky, Pini Taib, Benjamin Greenbaum, and Ilya Gelman for reviewing my presentation, Seth House, who gave me the inspiration for having a single dispatcher as a subject, and Andre Stotz, who gave me an inspiration regarding all what functional reactive programming means. Thank you. We are recruiting. Wait, I'll do that in a way that someone might see actually my email. We are recruiting. If you like what you just saw, you are more than welcome to approach the email you see here. And another thing, we have the code you saw in two repositories. I've uploaded my own repository of RxFRF, which is a baseline that shows this approach, demonstrates this approach. And you also have the game itself under the second link. So thank you.